So you couldn't get it to hold the pilot?
Yeah, the pilot wouldn't stay on.
Okay. Gas is on, right? Alright, it's lit.
These little boxes go out, or?
Yeah. Yeah, you might want to check your warranty. Looks like you're right on the edge of still being under warranty. So, oh, there you go, blue. It always comes up blue?
It was giving me the red one.
Oh, was it?
Red.
Oh, okay, good. Hopefully it'll do that for me. But yeah, 2018 is the cutoff year. So whatever date you bought it this year, right?
Like 5 years ago.
Yeah, you get a 6-year warranty.
Oh, okay. Yeah,
you get a 6-year warranty. So if you need parts or something, like a new valve or burner assembly or whatever, the Rheem will send it to you. You could try and return it to Home Depot, assuming you got it from there. And they might do something for you, but you can always take a picture of it and call Home Depot, give them the serial number, and see how much you got, because you might be able to like take it in, get a replacement. You know,
like the whole thing, or?
Maybe you're right on the edge, so they're probably going to want to prorate you.
Yeah.
They're probably not going to want to hand you a new water heater, but you never know.
Oh, yeah,
Maybe you paid for the extended warranty. You know.
Yeah.
Yeah. Oh yeah, it's going out, huh?
Are you doing the same thing, or?
Yeah. Well, that's what we want, though.
Oh, okay.
We want it to do that while I'm here. You know, we don't want it to just work, because then we're going to be at a standstill, kind of wondering what's going on, right? So what I'll do is I'll measure the voltage that's coming out of it. Oh, there you go. 1.2. Yeah. So it's doing a 2 flash. 1, 2, which is saying that the thermopile voltage is low, right? It's saying it's low. So let's verify that. All right, we want to verify that.
Where does it get his voltage?
That's the truth. So it converts the pilot flame, the heat from the pilot flame, into electricity.
Oh, wow.
Yeah. So that's kind of how it proves that there's a pilot flame. Because it doesn't want to just start dumping gas in there unless there's a flame to ignite that gas, right?
Gotcha.
So it's like a safety thing, but it's also it also creates enough electricity to power the circuit board.
Oh, okay.
Yeah, so we're gonna go ahead and.
Is this a common thing that these things do?
Not necessarily a 2 flash like that. You don't see a lot of them within 5 years. You know, the thermopile should be in pretty good shape. That's why I want to verify it. If it was like 10 years old, I would think that that's probably legit. But I have a feeling, just because you were telling me kind of what was going on, and I kind of have a feeling I might know what it is just because I work on so many of these.
Oh, nice.
Yeah, but I could be wrong. I'm always wrong all the time, so. But we'll see what it's at, because if it's at a decent voltage,
this should pick it up.
oh yeah, this will definitely pick it up. It'd be nice if I put it on the right setting. Yeah, so you're at yeah, it's going up pretty good right now. So we're at I don't know if you can see it here.
Yeah.
There you go. So we're climbing pretty rapidly, so that's a pretty good sign. When the numbers go up fast like that, that's not great voltage, but it's enough to run it.
Oh, okay.
That's enough to run it. So we'll top it out and see what it comes in at.
What's a running voltage?
So a new one is a new thermopile. That's what they're called. Is about 750, 800, right? 750, 800 these are millivolts.
Oh, okay.
So the closer we get to that number, the better. And then it knocks out about 100 millivolts while it's running.
Okay.
So it'll, like, let's say it comes in at 650, it'll run down to like 550 because it's powering the motherboard. So it'll run down. So it should be knocking it down. You know, let's say it's 530 or whatever because it's starting to slow down a little bit. Then it should be running at about 450, but that's enough to run it. So I'm thinking you might have a slightly clogged pilot tube. So the pilot tube might have a little bit of debris in it, little sediment from the gas line could get in there because it looked a little bit small. And if the pilot flame is smaller than it should be, then that'll reduce your voltage, right? And it'll cause that kind of feedback loop. Or you can get a bad valve. So if the valve is bad, it'll throw a code too. So it kind of looks like you should have enough voltage.
And that's just from the pilot?
Yeah, this is just from the pilot flame.
Oh.
So you're at 557, 558. I mean, it's still kind of climbing. So I'm thinking it's probably the valve. Or it could be the circuit board. You got a bad circuit board, maybe the circuit board is just a little buggy. Sometimes it's that too. So it's like boom, boom, or it's like one of three things. This is really all that. Everything you see right here is pretty much, like everything that's inside there is just dumb, right? It's just a piece of metal. And then all this pilot assembly is kind of what creates the, which allows you to have the pilot flame, and then the voltage comes back through these wires, and then, your spark comes down to ignite it, and then the valve itself just opens and closes and lets the gas in. Right, so you're at like 563. You're pretty much, so that's enough. I mean, that's not great, but that's enough. I see that a lot. That's like a pretty good average, right?
Okay.
So I think it shouldn't really be throwing that code. So if it's throwing the code and it really shouldn't be, then we got to start looking at the valve, see if we can't get some more voltage out of it. So. You got a little bit of water. You got just a tiny amount of standing water in here. So what happens is sometimes these plastic drain valves, where they're screwed into the tank, they go bad at that point and they leak water, and you'll see like a lot of rust and stuff in the front. Or you get rainwater that comes in.
I think it was a rainwater because I left it open like this when I was.
Oh, okay.
I was like, yeah, fuck this shit.
Yeah. Yeah. So what can happen is rainwater gets in here, right? And it gets into this insulation on the side. It soaks right into it, and then that's how it gets. Yeah, I'll drill like a hole. You don't care if I drill into the
bottom.
Into the bottom. We'll drill a hole in here, and that way, if you get any more rainwater, and we can just kind of drain it out.
Okay.
And that'll help it just run better. It'll help it get air. So by opening this up, I'm allowing air to get in through here. There's little like holes and stuff right down here on the side. This insulation is just to help it work a little more efficiently, but at this point, being 5 years old, right, being all rusty and crusty and stuff, it's like, who cares about that? I mean, its days of being super efficient are probably over. There we go. So yeah, it depends, the life expectancy. You start seeing problems right around 6 years,
Oh, really?
Right around 6 years. They give you they put an anode rod in here, which is like a soft aluminum rod.
Oh yeah, I was actually looking into it, but
Mm-hmm.
I don't understand where it's going. Yeah, there's somewhere up here, right? It's like a big long one that goes all the way.
Yeah, that's like the #1 thing you can do to keep the water heater going.
Oh, okay.
So if you replace that every 3 to 5 years, it should theoretically just keep going. If you flush it, what I recommend if you want to keep this one going, change this over to a brass drain valve. You know, they sell them at Home Depot for maybe 20 bucks. Or you can pull it out and get a brass nipple with a cap, just like a plastic PVC cap. And then you shut the water off to it. It creates a vacuum, like when you put your finger over a straw that has liquid in it.
Okay.
It'll hold that liquid. And then you unscrew it. You kind of do it quickly because it'll only let as much water out as air can go in. You put a little Teflon tape and pipe dope on the ends of the thread and just crank it down. And that'll prevent any future problem, because I get tons of people call me up and they're like, oh, it's full of water, you know, it's shot, it's done, you know, do you have one? And I'm like, well, send me a picture. And they send me a picture and I see the drain valve and I can literally see with all the staining and scarring on the side. And I said, well, let me come out and drain it and change that. And then I never hear it.
How would you drain that? The whole thing comes off?
Yeah, it unscrews. There's like a section right here you can put a like a crescent wrench on. And when I grabbed it and turned it, I wanted to make sure. So it's moving a little bit. Me just turning it. And you just take, if you undo this, water will come out. If you crank on it back here, you want to go slow and kind of get it going. And once it's loose enough, you shut the water off. And then you get the new one ready to go, and you can put a towel or something in here. It doesn't really matter now because we drilled holes, so if water runs down, it's going to run out, right?
Oh, okay, yeah.
Yeah, it's gonna find its way in here, and then it's gonna find its way out.
And what am I looking for? So when I want to change that part, do I just tell them?
It's just a 3/4. You can put it. Everything's 3/4 inch. Everything that's tapped into this water heater is 3/4 inch. This is that temperature pressure relief valve. All the nipples on the top, everything's 3/4.
Oh wow!
So you can get a 3/4 inch brass drain valve that's got, or you could get like a hose bib, like you see on your house.
Yeah.
You know, a little turn type, any type you want, quarter turn, whatever.
Oh, okay.
And you can thread that. You get a female to male. It has to be male going in, and then you just put a little pipe dope or Teflon tape on it. You just want something that it really isn't PVC. If you really wanted to put, you could do like a Schedule 100 PVC or something. If you wanted to, because it's just those parts are cheaper.
Oh, okay.
You know, it's like $6 for that and $1.50 for the nipple versus $20 for the brass.
Yeah, yeah.
If you wanted to go less expensive.
And that's what it is for, kind of like to do kind of maintenance into it?
Yeah. I mean, that's basically to drain it if it's ever leaking, or to move it or something, or to, you know, if you change the anode rod, you got to release a little water out of it because it's all under pressure. Because the house water pressure is moving through it.
Yeah.
So let's see if we got any more voltage. So anyway, there's a lot of minerals in the water, and then those minerals react with the tank because the tank is steel. And even though it's lined, it's got a glass lining and stuff, it's heated. So the water's hot, and that helps release everything. And so these minerals want to attach. They're looking for something to attach to, so you give it this soft aluminum anode rod to chew on, and so it goes after this thing. And you should see them when they're brand new. It looks like a perfect cylinder of aluminum, and it takes about 3 to 5 years to eat that thing up. And once it eats it up and it has nothing else to go after, it starts going after the tank. It's almost like a barnacle. It'll kind of attach itself and start, you know, erode it. It attaches to the steel, and then the steel gets exposed to the water and it starts oxidizing, and then eventually under all that pressure and heat and that little thing chewing away at it, it creates a hole, and then, you know, next thing you know, you got a leaking water heater, right? So most people, you know, they don't do anything. They buy a water heater, they hook it up, you know, they cross their fingers, and but that's kind of like the #1 maintenance thing that you can do. Well, let's hope we get a little more voltage.
Do different cities have different type of water?
Exactly. Yeah, depending on where you're at in the county, right? So like Spring Valley, that's literally named after a spring, right? So different parts of the city have different types of water. And then, you know, just depending where it's coming from, right?
Oh, okay.
So maybe in the mountains you might have a higher mineral content, or down south, you know, like towards the border of the water is probably going to be different down there. So it started slow, and then it really started ripping through the numbers. So we'll see what we get. Hopefully we get a little bit more voltage here. I wouldn't mind getting it up to like 650 or something. I'd feel a little bit better about that. But yeah, it's not really old enough. Sometimes they get dirty because the flames on it, so they build up like the scarring material, you know, that's on there, like ash or something.
Oh, okay, yeah.
So sometimes you get a little bit like
those torches, right? You light them up and
yeah, it just gets burned.
Yeah.
You know, it gets burned and then it builds up that carbon. You know, the fuel just burns on top of it. So we'll see. We'll see what we get here. This thing's supposed to come with like a little stand. So we'll hopefully we'll gain a little bit more. I think we're at 567, 596. Well, at least get me to 600. 597. So it's still going. I'm just hoping to hit it. We're gonna hit it. No, it's kind of hanging. It's hanging at 597 there. 598. All right. Not the 2/10 of a millivolts really gonna really make or break our success here. So we'll call it 600. We'll go ahead and round it up. Let's see. Come on, get to 599. No, it's holding steady. But we got a little bit more. So let's see. Let's see if it's. Yeah, see it. It doesn't even want to. It doesn't even want to come on. Yeah, so I plugged it in and it doesn't even want to turn over. Yeah.
Oh, is that like a power source?
Yeah, so this is like temporary. Oh, there we go. There you go. So now it's coming up. So this is temporary voltage, right? It's basically a battery. What's it doing? 1, 2, 3, 4, 5, 6, 7. Yeah, so now it's communicating properly. It's telling us that the valve is bad.
Oh, really?
Mm-hmm. Yeah, and it's not kicking over. Well, I should have just done this to begin with, huh? So this is
I mean, I learned a lot from what you did.
Yeah.
This is good to know.
Yeah. Yeah, so this thing is
Especially your viewers, huh?
Oh yeah, for sure. Yeah, this I made. You can't.
How much are you running it with?
You can't. It's I have 3 volt batteries.
Mm-hmm.
Or no, it's 3 volts. So it's 1.5 volts, and 1.5 volts makes 3 volts, right? And that's too much voltage.
Oh, really?
So we did a bunch of testing. Yeah, I know this old guy, Walt. He's like an electrical engineer. And I said, Walt, I work on these valves all the time. I need can you tell me where to buy a 750 millivolt battery so I can just, because it's all DC, so I can just, you know, stop screwing around and I can diagnose valve problems right away. And he goes, you can't buy a battery that's 750 millivolts. They only sell them, you know, 1.5 volts. That's how they sell them. You can't do that. And I was like, oh, that sucks. And he's like, he goes, but we can make one. And I said, all right, let's do that, you know. And he goes, you take a resistor. He goes, you take a resistor and you put a resistor in line and it'll step that voltage down. So you're resisting that voltage, right? And so we made that. It's real simple to do. You just buy a resistor. They're like $1.50. And you solder it inside the line that's coming, the hot coming from the battery, right? In line, you can't put it in wrong. And then when, so if I measure it with my voltmeter, it comes in at 1500 millivolts or 3000 or whatever it is, right? Because it's 3 volts. But as soon as it's under load, it drops down.
Oh, wow.
Yeah, it's funky.
So cool.
Yeah, I know, it's cool, huh? And it drops down, and it doesn't work on every single valve, but it does work on these, which is nice. Yeah, and then we tested it, and then we made one that was variable, so you could actually adjust your voltage with a dial, right? And that was pretty cool, but it was like he made it way super complicated.
Over-engineered.
Yeah, he like over-engineered the crap out of it. Well, first of all, it's dangerous, right? So it's dangerous because you can basically pump gas. You're tricking your water heater into dumping gas in there without your pilot flame.
Oh,
So you can flood that combustion chamber with gas,
Next thing
and
you
then
know,
hit
you
the
have a
clicker, and boom! And believe me, I've done it. So
Next
it's
thing you know, you have a rocket.
exactly. Next thing you know, you've blown the inside of your water heater out, all right? So you don't really want to be selling those things because people will try and run their water heaters on them, you know,
Wow.
which you don't want.
Yeah, that's
So I just use it for testing purposes to try and
maybe for a licensed technician, you know, something like that.
Yeah.
Area.
Yeah, I'm sure you could do it with AC. You could probably convert AC to DC and then step it down, and then you know, have something that you could plug in that just kind of, I mean, that thing will actually run for a couple hours before it drains the batteries down. So you could actually get like a tank of hot water out of it.
Oh, nice.
So it's kind of nice in an emergency.
Yeah, definitely.
Just to fire it up, but your valve's not kicking over, and so these are all the telltale signs of a valve that's shot.
Oh, okay.
Yeah, because your valve won't even start. So I was going to put the circuit board on there, but I think we're in the same boat with that. So we're just going to go ahead and put a different valve on. So we drained holes in the bottom of the water heater to get the water out. We actually changed the valve, but we're not even really 100% sure that this valve is bad anymore. So yeah, keep this someplace. Okay. Right, that's yours. This cover is pretty much junk. This thing's a liar. Right. We measured the thermopile voltage. We got another like 50 millivolts out of it, and we changed the circuit board. So this is off of like an A.O.Smith. I just use this one because it accepts the chamber sensor. But otherwise, any motherboard will do, or circuit board will do. But yeah. Here, let me turn the light off for you. See it going?
Yeah.
Yeah, it's going. I put it on B.